Hello, I'm Jerry Winslet along with Mike Dial, and in this course we're going to be talking about tankless installation and installation-related troubleshooting. Before we begin, let's talk about actually what comes in the box.
That's a good idea, Jerry. When you first get a tankless water heater and you open up the box, there's going to be a few very important things that are inside. And the most important thing is going to be the packet that includes the installation manual.
Okay.
So you need to familiarize yourself with the installation manual and the different parameters that are associated with this. Now,
Okay.
also in this packet, with our models that are 199,000 BTUs or greater, we're going to include the Easy Link communication cable,
Okay.
which will allow up to 4 of the same model of water heaters to communicate and work together.
Right. All right.
Something else that's going to come is the coupling.
Okay.
Now, for our condensing water heaters, this is going to fit here in our outlet on the top and allow us to transition into the PVC.
Okay.
We're also going to include some termination screens, and what these are really just debris screens so to keep anything from getting out of the venting, and these need to be installed at the terminations outside.
Okay. I know we also have one more piece of
And this
information here.
This is the maintenance sheet, so it's located in a packet inside the front cover of every tankless water heater. And what this is just an abbreviated service handbook.
Okay.
So it will go over all of the different troubleshooting scenarios, whether we're getting an error code. It will also give all of the error codes that are specific to this particular heater, and this sheet is going to be different depending on the model that you get, so it's going to be unique for that model.
Okay.
On the back side of this sheet, there's going to be an exploded parts view, so if we need to do any work to it, we can see how it comes apart, how it goes back together, as well as a parts breakdown with all the current part numbers.
All right.
Indoor heaters are also going to include the power cord, which is pre-wired in, so we just have to plug this in.
Okay.
But our outdoor models, because they're going to be weatherproof, we can't have this display that's shown. So
Okay.
outdoor models will include the appropriate remote control that can be mounted up to 400 feet away using 2-conductor 20-gauge stat wire.
Okay. All right.
Outdoor models, I'm sorry, also will have to be field wired. So there's no plug on those. You'll have to wire those in yourselves. So depending on which model you get, you may get a remote that looks like this. This is going to be for our condensing and our new ultra-low NOx models, or on our older models, you may get the RE30 remote, which looks a little bit different.
Okay.
Now, for our models that are 199 and above, the 199,000 BTUs and above, you need to get the appropriate remote because there's 2 different remotes that are available that have 2 different temperature ranges, depending on what your application is.
Okay. All right. Let's go back to the indoor models. Now I know they both have this has an on-off switch on the inside, correct?
It does. It's got an on-off switch on the inside. This on-off switch that's here on the display is really just going to be an enable or disable switch.
Okay.
So even though we may push it and get that orange standby light to go off, all that does, we can still flow water through the heater. The heater's just not going to respond in heat, but we can still access all of our diagnostic information as we're going through and doing some troubleshooting. So this does not kill power to the water heater.
Okay.
If we need to do some work on the water heater, inside this front cover, there is an on-off switch that you want to turn off so that you know that there's no power there, you don't get shocked.
Yeah. So there's no power to the water heater once you've done that.
There will be power here at the fuse block that comes in that
Right.
protects all that, but everything past that, the best thing to do if you have to work on the water heater, of course, is always just to unplug it or go
Okay.
back to the circuit breaker and turn it off.
All right. Now let's talk about installation on these units, and let's kind of go, connection by connection. And we're going to start with the condensate because this is a condensing heater we're going to be talking about. Let's start with the condensate connection. What do we need to be thinking about when we do installations on this unit?
Okay, well, with a condensing heater, we are cooling those flue gases down to the point that they're going to condense. So all of that hot, humid vapor is going to condense here inside of the heat exchanger, and we've got to get rid of that. Now, what we will have is we'll have some acidic condensate. So condensation that's formed by combustion is acidic. So depending on what your local codes are, you may need to neutralize that back to about a 7 pH.
Okay.
So we have a condensate neutralizer that's available that you can hook up in series with this.
Okay.
And that will, depending on how much water that you use, hot water, and how much the heater runs, that will have to be changed periodically.
Okay.
So every so often you'll need to test the pH of the condensate leaving that neutralizer. And if we ever see a pH that falls 6 or below, it's time to replace the neutralizer.
How much condensation can this produce?
So we're going to produce about 1 gallon per hour per every 100,000 BTUs of heat input. So
Okay.
this heater being 199,000 BTUs, if it ran consistently for an entire hour, it could produce 2 gallons an hour.
Okay, so, and always adhere to your local codes when we're talking about disposing of the condensation, because I mean, there's some places where you have to use a neutralizer, and other places where we can just pipe it outside, I think.
You can pipe it outside or into an approved drain. Something else to keep in mind with that condensate connection is that because it is acidic, you want to make sure that you're going to use PVC
Right.
or vinyl tubing. You don't want to make this connection into a piece of metal pipe, say copper, which will look really pretty, but unfortunately the acid in the condensate will eat that away and it will start to leak on the floor
Yeah, look pretty for a little while.
for a very short time.
All right, let's talk about the hot and cold lines. One of the things I noticed that's on this installation is isolation valves, and that is very important when we're installing these tankless heaters.
Yeah, isolation valve kits. Now these don't come with the heaters, and I have some that are loose here,
Okay.
and we can talk about them.
All right.
Right. What these do is when we install the isolation valve kits, and these should be installed with every tankless water heater, we want to make sure that the union is up closest to the water heater. That's going to be the correct way to install them. Now we've got one for the cold and one for the hot.
Okay.
And what this does is this allows us to turn this valve and allow flow through the water heater, or if we turn it the other way, we isolate the water heater from the plumbing system.
Okay.
But because we've got 2 connection ports, when we've isolated the heater, if we turn both of these off, we can connect our hoses for service, right,
Okay.
which would be like washing machine hoses, and we can open up this other valve. This would normally be closed. We would open that up, and we'd do that on both of these. And this
Okay.
allows us to pump our solution through to remove any hard water minerals that are going to build up on the inside of the heat exchanger.
Okay, so good for maintenance. Good.
Now the hot connection also includes the pressure relief valve.
Okay.
Now most jurisdictions will only require a pressure only relief valve for tankless water heaters, but check with your local codes, and if they require temperature and pressure, this part will have to be field supplied.
All right. So, well, obviously these are blue and red, so we know hot and cold. But people get that confused sometimes. They can't get them reversed, can
They do. Well, and the connections on the bottom of the heater, they're stamped on the heater hot and cold,
Right.
but they may be hard to see, and so which one is which? And it is important, it's very critical to make sure we get these connections connected correctly.
Okay.
Because we can, it's very easy to switch those connections. Now, if we have them hooked up backwards, and the cold to the hot and the hot to the cold, water will still flow through the water heater, but the flow sensor won't be able to detect that flow, so we won't be able to begin heating. So having both of these connected the right way will allow flow to be sensed as it flows through the water heater.
Okay.
All right, and something that if you have that reverse connection, what will happen is you'll open up a fixture, you'll have water flow that comes out, but the heater will just remain in standby
Yeah.
and it won't do anything.
Yeah, because it can't spin that propeller in that flow control. Yeah, I understand that. Okay, let's talk a little bit about installation and water on this. You know, now a lot of people might put this on a recirculation system. You know, is there anything that we need to keep in mind when we're using a recirc?
There is. Now, the recirculation needs to be sized correctly depending on what the length is out to our furthest fixture and then coming back. And we have to maintain at least 2 gallons a minute
Okay.
of flow when the recirculation pump is running.
All right.
And we understand that when you open up a hand sink, you're going to have less than that for intermittent use. But when the pump is running, we have to maintain at least 2 gallons a minute.
Okay.
And for a single heater, it's really 2 to 4 gallons a minute. And 4 gallons a minute, what that will do is that will allow more of the burner to come on and let us use more of
Right.
that space, which ultimately will mean that the hard water minerals that are inside the water heater, instead of building up in just one section under low flow, bringing on part of the burner,
Right.
we'll spread that out. And so this is going to mean that we can go longer in between maintenance cycles.
Yeah, and you get more of an even burn across the whole burner.
Yeah. If we fall below 2 gallons per minute, what can happen is that we're right at the threshold of the heater being able to activate and come on, and so the heater may flash fire.
Okay.
Come on for just a very short burst and then shut right back off. And that can cause condensation to form along the heat exchanger, which can damage the heater and also cause some failures like 391,
Okay.
ignition failures 111, and combustion failures 991.
Okay.
We can't have the pump run all the time.
Oh, okay.
All right, if the pump runs all the time, even at the correct flows, we do have to generate at least 15,000 BTUs of demand, which
Okay.
doesn't sound like very much, and it's not, but we have to generate that much. And when the pump runs all the time, as the line temperature goes down and it comes back on, we hit that threshold, the heater comes on, and it does that same thing. It does this short cycling, short fire. So the pump has to be controlled externally as well by an aquastat
Okay.
with at least a 15-degree differential. And that differential is going to mean that if we have the water heater set for 120, we're going to get that entire loop warmed up to 120, and then it's going to have to fall 15 degrees before the pump comes back on and starts pumping that again.
Okay, all right, that makes sense. All right. Now let's talk about if you have multiple heaters. I mean, is there something that we need to keep in mind with using a recirc line?
So with multiple heaters, so if we have a larger application, maybe a large home that our flow demands when we're peak use may require more than one heater to come on. Normally for our recirculation, just to keep our lines warm, we don't need more than one. We just need the one heater.
Right.
Now the activation point of the second heater is going to depend on what our set temperature is. And for most homes, it's going to be around 120 degrees.
Right.
So what that means is that at 3.4 gallons per minute of total system flow, the second heater is going to come on.
Okay.
Now, when that happens, they're going to share that water load equally, and so then our flow through each heater is going to be half of 3.4, which is only 1.7. Now that's below our 2 gallon per minute minimum threshold, and what that will do is, again, now both of these heaters are going to have these very short operation times,
cycles,
and we're going to have the condensation that can form and cause damage again to the heater and cause some error codes.
Okay. So what do we do if that happens?
Well, the idea, Jerry, is to prevent that from happening. So in those conditions, we want to size the pump to provide enough flow that the second heater doesn't come on. So we want to stay, for 120 degrees, we want to stay below 3.4 gallons a minute of total system flow. So 3 gallons a minute would be ideal in that situation. Now, the higher we set that temperature, the lower the activation is for the second heater.
Right.
So you may want to contact our tech support team, depending on what temperature you need to set, to see what that flow should be maintained below.
Okay. Now, sticking with recirc systems, we do make a water heater, a tankless water heater, that actually has a built-in pump.
We do. So we have the P model, and P stands for pump. So we do have those available, natural gas or propane. You'll need to get the one that's appropriate for the fuel that you're going to use. Now they have a separate connection on the bottom for the return line that comes in.
Okay.
Very important to note that return line, you do have to field supply a check valve.
Okay.
That has to go in place of that return line. Now that's going to prevent cross connection, which would provide an easier path for the water to flow to the fixture instead of going through the heater. So without that check valve, we may get flow out of the fixture, but the heater won't recognize it and won't come on and heat water because it's not going through the heater.
So it does have a different control.
It does.
All right, so you can actually set it's got a timer set on there where you can set 2 different times for that pump to actually kick on, doesn't it?
It does so, and the idea is to keep the pump from running all day long. Now, it's still going to look at the thermistor on the return line, and so the pump will only come on if that temperature drops below the threshold that we've set it for.
Okay.
But we don't really need to keep the loop warm all day long.
Okay.
So the idea is to set the time periods where the pump can come on during the times when we would expect to use hot water.
Okay.
So any other time outside of those time periods, and it might be in the morning when we're all getting ready, and in the evening when we're making supper, getting ready for bed. But the rest of the time, the pump won't operate. We won't keep the loop warm. But if we need hot water and we open the fixture, this is still going to work like a normal tankless water heater.
Okay, it will. All right. With the pump model, if we don't have a recirc line yet and we purchase the pump model, is there a special way we need to install this?
There is, and of course the only reason we would purchase the pump model is if we intended at some point.
Right.
But we don't have to have it there. So if we're doing a new construction project and maybe want to leave that open as an option later to add the return line, we can still use this like a traditional tankless water heater.
Okay.
The piping connections are a little bit differently though. So the cold water inlet, instead of going to the cold connection here on the water heater, instead we'll take that to the recirculation connection.
Okay.
Because there's a little bit of extra piping that goes through that inside of the water heater, and we don't want that water to just sit there and become stagnant, which could promote some bacteria growth or something like that. So for safety reasons, we're going to take it through there, and that way we're always flowing through that loop and no water goes bad.
Okay. So with other tankless water heaters, flow is very important. How do we handle that with the pump model?
That's right, Jerry. So even with the pump model, it's still important that we maintain at least 2 gallons a minute of flow through the heater.
Okay.
And we can do that as long as we stick with the installation guidelines.
All right.
So we're okay to go up to 200 feet of half-inch inner diameter piping. That's from the water heater out to the furthest fixture and back.
Okay.
Or up to 500 feet of 3/4 inch inner diameter piping, again, from the water heater to the furthest fixture and back.
All right. All right. So that's a little bit about the recirc, and that's a little bit about the pump model. Let's talk about something else we talk about all the time when we talk about installations, especially with tank-style water heaters, and that's a thermal expansion tank. But really, we need a thermal expansion tank on every installation.
Yeah, we would recommend it on every installation, and the point being is we never know what's going to happen after the installation is done.
Right.
As families grow and things different change, we may have installed it without recirculation, then added recirculation after the fact, and it then becomes a closed system where we're heating water that's sealed in this loop. And when we heat anything, water specifically, the water molecules expand and they create pressure, and those pressures can damage the piping or they can damage the heater. So by installing a properly sized and installed expansion tank, we give an air volume. There's an air tank basically that's separated with a rubber bladder, and any water that expands, takes up more space, it can now move and compress this air, and it has a volume to go into.
Okay.
So not required necessarily for a tankless installation, but very much recommended. But anytime we're using recirculation, it is required.
Okay, and the big thing about a thermal expansion tank is always pressurize the thermal expansion tank with air to whatever the incoming water pressure is before you install it. You have to do that before you install it. Don't do it after. They are pre-charged, but you need to find out what the incoming water pressure is and then pre-charge the thermal expansion tank with air before you install it, then install it.
That's right.
All right, the next thing we're going to talk about is some things that, because we're talking about installation. So we put a thermal expansion tank on. We've got our hot and cold and our condensate line ran. One of the things that we can talk about is actually the water itself. We can get we got a way to pre-treat the water, right?
We do, and what we're really concerned about is going to be the minerals that are in the water, and we're going to call these hard water minerals, which are calcium and magnesium are our big ones. And when we heat water that has these minerals, and all water has them, those minerals are going to start to solidify along the heated surface. Now, in our tankless water heater, it's a series of small tubes, and we can build up very, very quickly.
So it sticks to the inside of those tubes.
It does, and what that does is it prevents the heat from getting through the copper heat exchanger and into the water, because that hard water minerals forms like a rock surface.
So it like insulates it.
It does. It insulates it, makes it harder, and so what that does is overheats the copper, which causes it to stress, and it can create leaks, and that's something that we absolutely want to avoid. So treating the water is critical, and there's different styles, and people have different preferences on how they treat the water. Water softener would be one means, and what we want to do is try to maintain between 4 and 7 grains of hardness. Now, between 4 and 7 grains of hardness, we're still going to have to do some maintenance.
Right.
We're going to have some of those minerals that are going to accumulate, and we have to do some maintenance. We're going to talk about that later.
Okay. But there's also maintenance on the water softener too.
Exactly. So that's a big thing. So some common complaints with water softeners is that people don't like it because their skin feels a little bit different in soft water, so they stop using them. Or we do have to maintain them. They have to recharge the brine tanks and get the salts in there, and a lot of times that doesn't get done either. So very quickly, they can either be not used at all or lose their effectiveness if they're not kept up. So it wouldn't be my first choice, but as long as you keep up with it, that is a good option.
Now we have another choice though.
We do. We have our product preserver, and this is a template-assisted crystallization process. So there is a media in there, and we don't actually change the water chemistry. The easiest way to describe it is not actually how it works. The easiest way to describe it is that it knocks these sharp edges off of these minerals, so that as they solidify, they don't stick to the water heater. They just flow through harmlessly.
Okay.
Now, eventually, they'll redissolve back into the water, but after we get out of the water heater, we're not really concerned with it because we really want to protect the water heater. So this product preserver has a cartridge. We would recommend that be changed every 2 years, and it will support flow rates of up to 7 gallons a minute.
Okay.
Now, if we have some peak flows that are going to be above 7 gallons a minute, that's still okay, but we want to try to stay 7 gallons a minute or less. And if we're going to have consistent flow rates above 7 gallons a minute, we want to select a product that's going to allow for those higher flow rates.
Okay, so when we install this, is this going right in front of the water heater, or do we put it somewhere else?
The best place to put it, especially with a tankless water heater, is right before the water heater, because again, we're really concerned with protecting the heat exchanger. And that way, any water that goes through doesn't stick to the heat exchanger, and we don't care what happens past that. But there are a few critical things that we have to keep in mind. It's got a maximum temperature of water that can come into it, so it needs to stay below 100 degrees.
Okay.
So if we're using a recirculation system, wherever our recirculation return comes back in, the product preserver needs to be upstream of that, so we're not passing that hot water through there.
Okay.
One more thing with the product preserver is that if we're putting a new installation in and we've got brand new copper, we need to let that copper age for about 3 weeks. So we can go ahead and install the outer cartridge, just remove the media, and put the media in after 3 weeks, because as the copper ages, it can give off some things that can damage the media.
Gotcha. All right. So don't install the product preserver and install it right as soon as you install the water heater. Let it take the media out and let it sit there for at least what'd you say, 3 weeks or 3 days?
You can go ahead and install. You'll see the cartridge there, and inside that cartridge is the media. So you can go ahead and install the housing and the cartridge. Water will still flow through there, but wait 3 weeks before you put the media in.
All right, so that's the product preserver. Next thing we want to talk about is gas. So, we use gas, and gas piping is always important when it comes to tankless water heaters, because sometimes, like on a retrofit application where you had a water heater that's a 40,000 BTU water heater and you're putting in a 199,000 BTU water heater, you may have to do some upgrades, right?
That's right. And one of the things with tankless is we actually are going to use the same amount of gas to heat the same amount of water, because there's a heat content for water. But what we're going to do is we're going to use it in a much shorter period of time, because we're heating it on demand here.
Right.
So we're only heating water as it flows. We have to make that entire difference from the coldest incoming water to the 120 or whatever temperature that we want it to be delivered at. Because we're using much more gas in a shorter period of time, we have to be able to get the gas there quicker.
Okay.
And that means that we need a larger gas line.
Right.
So the minimum gas connection for most of our tankless water heaters is going to be 3/4 of an inch.
Okay.
Now that still needs to be sized correctly. National Fuel Gas Code has some sizing charts that help you out there, because the longer the pipe, the more friction and the less gas we can get through.
Okay.
Now our 140 model uses a 1/2-inch gas connection. It's much lower BTU, but that's the only model that we can use a 1/2-inch gas connection. And still, even with that one, still needs to be sized correctly and follow the National Fuel Gas Code.
Yeah, because you have to take into account all the gas appliances that are using gas in the home or in the business. So really, you always have to bump that off the National Fuel Gas Code and the owner's manual when it comes to sizing gas line. Now, is there anything we need to think about whenever we're putting the gas line on? I know that we've got our connection here, right over here. We need to do a couple things, right?
Yeah, so our gas connection here, now this is it is metal, but it's a pretty frail metal. And when we're making those connections, it's softer than the steel piping. So when we're making those connections, we want to make sure that we don't twist that too much, because it can break it. So we always want to make sure that we use a backup wrench to hold that in position as we're tightening it to prevent all of that from turning.
So should we hard pipe these, or can we use like a flex line?
Yeah, hard piping is okay, and it's always going to be okay, because that offers the least resistance. Now, some areas, or because it's convenient, you may be required to use a flexible type connector.
Okay.
And we would recommend that you avoid the appliance style connectors. These are going to be the yellow ones with the tags on
Right.
it. And the reason being is they have very loose corrugations, and they actually taper down, most of them, at the ends, and they restrict.
Okay.
So these can create noise issues as the gas is flowing through them, or they can prevent us from getting enough gas to the water heater, which, if we don't get enough gas to the water heater, this could cause a 991 error code, a combustion error code.
Okay. And we want to kind of stay away from making any sudden bends, right? Any 90s or anything like that on.
Stay away from any sharp bends. So if we're going to use flexible gas connections, we want to make sure that they're as straight as possible. Any bends need to be gradual, and we would recommend using an actual gas piping material, making that gas connection yourself.
Okay. All right. What about a regulator? Should we? I mean, we're using 199,000 BTU. Should we have a regulator installed with this?
The need for a regulator is going to be really determined by what the gas pressure is coming in.
Okay.
So if we're delivering at a PSI 2 or 5 PSI pressure, which may be common in some commercial buildings, we do need a regulator there to take us down to the 14 inches or below, which is about a 1/2 PSI. Now, most homes are already going to be delivered at low pressure, and so there's no need to put a regulator in before those.
Okay.
If we do need a regulator, though, follow good practice. And we would recommend getting that regulator probably at least 3 feet away. And what that will do is that will allow more of a volume of change, so that the regulator can react more gradually instead of doing sharp adjustments. Now, regulators also, depending on how they're installed, they may use a vent limiter, which is a check valve if something happens to prevent gas from leaking into that space.
Right.
Or they may have to be vented, so that if something happens, we vent that gas outside where it's safe.
Okay.
So with the vent limiter, it needs to be always installed in the upright position. Right?
Okay.
If it's laid on its side, or if it's upside down falling down, that's going to prevent the regulator from operating. And if we're going to use a vent, we need to keep in mind that for every 10 to 15 feet of vent length, and follow the regulator manufacturer's instructions on this, but for every 10 to 15 feet, we're going to have to increase the diameter of that vent 1 nominal pipe size to allow enough flow to go out.
Okay, all right. So that's a little bit about the piping, gas piping. Let's talk about combustion air because you have to have those three things for combustion. You got to have air, fuel, and a source of ignition. This is just one of those things to have a flame. It's combustion air, and we need a lot of it for these units, don't we?
We do. So the National Fuel Gas Code says that we have to define a space as confined or non-confined, and that's going to be determined by whether there's 50 cubic feet of space for every 1,000 BTU of input
Okay.
or not. Now, if we have 50 cubic feet, and when we're talking about 199,000 BTU water heater, that's roughly about 10,000 cubic feet. It's
a lot.
It's a little less, but it is a lot. So most applications, we're going to have to either provide air for combustion a different way. Now, one way is that we can use a two-pipe system, where instead of this
Right.
one that's pulling room air here, we would take that pipe and get our combustion air from outside. Although National Fuel Gas Code does allow for some other ways to get that extra air into the room, and refer back to your local codes, National Fuel Gas Code, for the ways that you need to do that.
Okay. Now, when we're using room air, this is exactly how we want you to have it installed, correctly?
Absolutely. When we're
Correct.
using room air, we're just going to turn an elbow directly off the top of the water heater and make sure that we get our termination screen in there that's going to prevent any debris from falling back in.
Okay. And when we talked about confined space, and plus when you're in here, you don't want to have, stay away from dryer, laundry rooms, things
Right.
like that, where we get contaminated air can come back in there.
So we may be installing this in a home that's in a basement that has plenty of room, but it's important to remember what else is going on in that
Yeah.
basement. So a lot of people are hobbyists, and they may do some woodworking or something that's going to put a lot of sawdust in the air, or especially if we're close to a laundry area. We're going to get some dryer lint, and we're also going to have the laundry chemicals, the soaps and the bleaches and things like that that are going to get in the air. And what they do is they can come in here and they can start to affect the combustion and start to cause failures. They can wear down the parts in here and cause failures.
Okay. So if that happens and that's all we got, then we need to go ahead and run this outside and use, the two-pipe system.
Yeah.
But there are some things we need to keep in mind when we do that, right?
And I would recommend the two-pipe system, just like we did with the expansion tank. You never know what's going to happen with an installation. Even if we put this in a great big open space,
Yeah.
they may later determine that they need to use that space for something else and finish that space out. And what's going to happen is they're going to put this water heater, they're going to build a closet around it, and now we don't have that air.
Or they start putting stuff in that room, and that cuts away on that.
Cuts away a
cubic
lot of
feet, yeah.
the availability of air. So if we go ahead and run that second pipe outside, draw our combustion air from outside, we're covered down the line no matter who comes in and does anything behind us.
Okay, so let's talk about that. If we're running two pipes, there are some things we need to keep in mind when we're, especially on the terminations, how far apart they can be. Let's talk about that.
Okay. The most important thing is to locate that intake air termination
Right.
somewhere where we're not going to, just like if it's in a laundry room, somewhere where we're not going to pull in any contaminated air. So
Okay.
away from dryer vents, away from any other exhaust gases from any other appliances, maybe a furnace or a stove or even a gas dryer. And we do need to keep our terminations separated enough so that we don't pull back in the same exhaust air that we
Right,
just processed,
yeah.
right? And
Recirculate that,
recirculate the flue gas, and that's going to not give us enough oxygen to burn, and that will result in a combustion code and 991 error code.
Okay.
So something else that people don't commonly think about is keeping this intake away from porch lights.
Yeah, bugs, right?
Bugs, right? We use hot water in the morning and we use hot water in the evening, and most of the hot water we use is probably between dawn and dusk. And those porch lights are on, and bugs are going to be attracted to that. And the fan on here is powerful enough that we can pull those bugs through there, and that can cause an air restriction inside the heater.
Okay, so just really keep that in mind wherever you're going to be terminating or you're pulling your air in, that it's not by some type of floodlight.
It is, and if you'll follow, check in the installation manual, there's a lot of different examples of how you can terminate when we talked about the clearances between the two of them, whether the intake is over top, or I'm sorry, the exhaust is over top of the intake, or whether they're side by side. And there's some different things where if we're going to come out really close, we may extend the exhaust further out to prevent that recirculation of flue gas. So check the installation manual. There's a lot of great scenarios in there, and they should cover just about everything that you'll encounter.
Yeah, and I mean, even in the installation manuals about what we're about to talk about too, the vent lengths. I mean, because when we're running a certain length, we may have to adjust some of the dip switches, correct?
Right. And you mentioned it before, we have to have a certain volume of air in order to be able to burn correctly. So when the fan is running, it needs to know how much vent is there so that it knows how much air or how much force to put behind the air so that we get the right amount of
Yeah,
air.
because the longer the vent, the more restriction you have, and the fan has to work harder.
There is, and different models are going to have different venting requirements. So always refer back to your installation manual as far as the diameter and the length that you can run the vent.
Okay.
Very important to keep in mind that if we're going to use fittings, if we have to turn an elbow, that those elbows are equivalent to 5 degrees of straight, or 5 feet rather. 90-degree elbow is equivalent to 5 feet of straight pipe.
Okay.
So that's going to take off of the total length of pipe that we can run. There is a maximum of 5 elbows that's ever allowed.
Okay.
And even if you have a very short run, and the math would come up that you would still be okay, on those shorter runs, those 5 elbows are going to be so close together that they're going to cause some restriction in the air.
All right. All right, so let's talk about the venting material now. I know we've got a condensing here and we've got PVC up here, but let's talk about all the different types of venting material we can use.
Well, let's start with the condensing because this is going to be our most
Okay.
common model. This
Okay.
is the highest efficiency.
All right.
And one of the
Yeah, you got
benefits,
some examples over there.
one of the benefits of being so high efficient is now we can vent with PVC
Okay.
vent material. We've cooled those flue gases down, so it's safe to use the plastic vents. Now, it does need to be Schedule 40 PVC, and it has to be solid core. We can't
Okay.
use cell or foam core.
Right, okay. All right, so solid core PVC, that's one. What else can we use with the condensing unit?
So with the condensing unit, we can also use the stainless steel. Now, stainless steel is actually going to be required anytime we're installing our non-condensing heaters. Now, these are not as efficient, so there's a lot more heat that's left in the flue gas, which makes it not safe to run the plastic. So we do have to use the stainless steel vent material. Now, we want to use something that's going to be category 4.
Okay.
So this is stainless steel. We're going to produce some condensation in here. The stainless steel is going to not be degraded by that condensation. And when installing it, always make sure there's an arrow, the airflow indicator. And this one connects a little bit differently than what our standard vent would.
Okay.
So normally we'll have a male and female in or male and female in, and we would normally run a male into a female out to our termination. And this one actually runs in the reverse. And so when the male in comes in here, that allows any condensation that does form to fall all the way back into the heater.
Okay, that makes sense. And we use this on condensing as well in certain situations, correct?
We do. Anytime we've got a condensing water heater and we're going to do recirculation, and if we're going to recirculate temperatures that are 140 degrees or greater, what happens is that the 140 degrees is the coldest water, and our flue gases have to be higher than that. So in those conditions, we won't be safe for PVC. We will need to use the stainless steel venting for those.
Okay.
One more thing on the non-condensing heaters.
Go ahead.
They are not as efficient, but they're right at the threshold of being able to condense those flue gases. And non-condensing heaters do not have any means to get rid of condensate. So what we want to do is we want to put some type of a condensate collector that's going to come right off the top of the heater.
Okay.
And this is our 3-in-1 product. And it's 3-in-1 because it's a female-to-female transition, which we will need for all condensing water heaters so that we can have the male go in and get our vent going in the right direction. Now this also, you see it's got a little stub here, and if we look inside, we can see that we've got a little cup. So as the pipe slides down in here, any condensation is going to be collected in this cup.
Okay.
And this is our outlet to get that condensation, and we can then take it through the appropriate type of material to whatever drain, and if we need to neutralize it, we can neutralize it.
Okay.
Now one other thing that this has, being the 3-in-1, is we've got a little air flap that's inside. And what this air flap does is this allows us to, especially in colder climates.
That's what I was going to say, yeah.
We would recommend this. When the heater comes on and fires, we'll open up that air flap.
Okay.
When the heater is off, and this is sitting in the correct position, and this can only be installed vertically, we can't install it horizontally like I'm holding it now. But when the heater's off, that air flap will close.
Okay.
And what that does is that prevents a draft from coming back through the heater, or at least it slows it down considerably, and prevents cold air in those extreme cold climates, those northern climates, from coming back and freezing water inside of the water heater.
So it's very important to install this the correct way.
Very important. So again, we do
That
have
can
an
be
arrow.
one of the troubleshooting.
It very much can be.
Yeah.
We have an arrow showing the way that the airflow goes. And if I install this upside down, a quick and easy way to tell is we can see where the seam is, where we've got our cup that's inside, and our outlet needs to be above the bottom of that cup. Now what can happen is when I've got it installed upside down, it's going to rest with that flap open. Now that's going to allow all that cold air to come back down through the heater, and we could potentially freeze. But what happens when the fan does come on, now it closes the flap and I can't move air through the heater, and I may get an ignition failure or I may get a combustion, a 991 failure.
Okay. All right. Now, this is the non-condensing and the condensing we've just talked about. We also have a concentric vent model, or the C model. Now that's a little bit different vent, and you've got an example of it there.
It is. So a concentric vent model actually uses a pipe in a pipe, and so the entire vent system will be constructed out of this material, and the two pieces will snap together. Now we use Centrotherm, which has got an easy snapping ring, so as they slide together, we snap this ring, and that gives us a nice airtight seal. And you can see that we've got a gasket on the intake and we've got a gasket on the exhaust material, so that keeps them separate. Now exhaust is going to come out through the center pipe and go outside where we don't care, and then through the pipe that surrounds that, we're going to be actually bringing air in, so air is moving two different ways through the two different pipes.
Okay, and that's this is the metal on the inside because we aren't in the 90% with the efficiency or the thermal efficiency on those, right?
Right. These are lower efficiency heaters, so they're about 80% or 0 to 0.82 on the UEF. And our heater is the Simplicity series or the C model heater. And what it will do, it can use this Centrotherm vent pipe that we use, or we can use any commercially available plastic on the outside, metal on the inside, concentric venting that would be for use with tankless water.
The big thing you want to keep in mind, though, is you can't mix and match the Centrotherm and whatever is there. Maybe you're doing a replace and place job and you're wanting to use some of the vent. It would be best for you just to go ahead and take all the vent out and replace it with all Centrotherm, or use all the vent that was there.
Yeah.
If
you've got existing venting there and you just need to make a small addition, go back and get that same type of venting. But if you have damage to the venting system, go ahead and replace it all with the Centrotherm vent system, and that will take care of it.
Okay.
We have two different concentric terminations.
Okay.
So this is where we penetrate through the wall and we're going outside to get rid of our exhaust air and to bring in our fresh air. So if we're going horizontally, and this termination looks pretty much like most of our concentric vents do. And so we discharge here out of the end, and that throws our exhaust gases out away, but we're drawing fresh air in from close to the house, and that prevents us from recirculating flue gases.
Okay.
But because this is a lower efficiency heater and it's non-condensing, again, our heater doesn't have the ability to get rid of that condensate.
Okay.
So if it can't get rid of condensate, we also can't get rid of any precipitation. So we need to shield it if we're going vertical. So we do have a vertical termination here. And you can see that this one's just a little bit different. So we've got a cap here on the top to prevent any snow or rain from falling down in there, which would come back and flood the inside of our heater. But we've extended it up above where our intake air comes in here. And this prevents us from recirculating flue gases.
Yeah, so we're pulling in air here, blowing it out here.
That's right. One last thing on the C model water heaters is we need to install the condensate collector. If we're going anything more, now if we're turning an elbow and go directly into a termination off the top of the heater, that's great. But if we have any vent pipe on there at all, because we've got cold air on the outside of the intake and warm air on the inside on the metal, it's going to cool it down. Condensation will be produced, so we want to collect that.
So is it a good idea just to do that on every installation, or?
Any installation that's any more than turning an elbow directly off the top of the heater into the termination. So if there's any pipe at all other than an elbow and one of the two termination kits, we need to have that.
All right, let's keep talking about concentric vent terminations. We have a concentric vent termination for our other tankless models, don't we?
We do, Jerry. For our condensing models, we're going to use the PVC concentric termination. Now, we're still going to run two pipes all the way up to the point where we penetrate outside of the wall. And this one's going to have the two connections, so it's important to get them connected correctly.
Okay.
So the connection that's going to be at the bottom of the tube is going to be for our exhaust, and that's going to let exhaust gases go straight through, and they're going to throw out away from the building. Now the connection that's on the Y is going to be for our intake, and this is going to allow the fresh air to come in the outer pipe, and that's going to draw it in from up along either the wall or the roof if we've installed it that way, and bring that fresh air down.
Okay. What about our non-condensing?
So non-condensings also have concentric termination. Now these are made out of stainless steel.
Okay.
And we've actually got a couple of different models that are available, and those models will shift just a little bit. They'll slide in and out together, and that's going to be to accommodate different thicknesses of wall that you may need to penetrate through. Okay. So it's important to make sure that you know the thickness of the wall so that you can get the correct kit for those non-condensing applications.
And something to really keep in mind is which pipe is going in which section on that concentric vent termination.
It is, and again, back to our condensing water heaters, if we're going to take that up vertically through a roof, even though we do know that these are going to produce condensate, and there's a condensate management system in there, we need to avoid any precipitation from falling down in there, because that could cause that condensate management to overflow. So if we go up through the roof with the PVC model, we need to take 3 foot of 3-inch PVC and insert that down into the cone that comes out. And then at the top of that, we're going to take a 90-degree fitting and a 45 and put our termination screen in there. And that separation, just like with our C model one, is going to prevent us from recirculating flue gases while still preventing condensation from coming and damaging our heater.
So what happens if I do reverse the intake and exhaust?
So if you reverse those connections when you hook them up, and regardless of which system that you're using, what will happen is we are going to start to draw air in from the top, but we're going to exhaust air out, and it's going to hit either the wall or the roof, and it's going to come up around that, and we're going to recirculate those flue gases, and that's going to give us our 991 error code.
Okay, so it's very important that we've got the exhaust going straight out, especially on that concentric vent, and then the intake is coming in on the side. Okay, now we are able to common vent these condensing water heaters up to 8, correct?
Right, we can common vent up to 8 condensing water heaters. Now they have to be the same model, and this is limited to the 240, 340, and 540 model.
Okay.
So we can't mix the models that are in there, but if we have all the same model, we can common vent up to 8 of them, and that can go up to 100 feet away.
Okay.
What we'll need is for each heater, we're going to need this non-return valve.
All right.
Okay, and it's going to come with an O-ring. It's important that we take this O-ring off of here. Now, inside of our collar here, there is an existing O-ring, but it's not round all the way around. So it's round on the outer edges, but it's just kind of got like a door sweep, a little flap. So we need to take that out, replace that with the orange O-ring. It's going to give us a better seal. Now, each one of the heaters that we're common venting will have to have this on the exhaust. In addition to that, we're also going to need, now if we're doing with polypropylene venting, that will go right into this.
Okay.
But if we're going to go with the PVC vent, we're going to need a PVC adapter. Now that's a separate part that you'll need to make sure that you order it, and again, for each heater. So what this does, there's an air check valve that's inside of here.
Okay.
And so when the fan comes on, it's going to move these two sections up, and that's going to allow exhaust gases to come out.
Okay.
Now, if a heater that is in the system is not running, what we'll do is that positive pressure in the vent system, it's going to force this closed.
Okay.
And that's going to prevent any kind of flue gases from going somewhere where we don't want them. We want them all to go outside. We've got a condensate trap that's built into this already because we're going to condense some in the flue system because this is already a condensing water heater.
Okay.
So this condensate trap, we have a ball check valve in there, so it doesn't have to be primed. It's ready to go as soon as you install it.
Okay. All right. So that's common venting. We common vent up to 8 of these together. But the big thing is we have to have one of those. It's basically a check valve. I mean, it's a backflow preventer.
It's an air check valve that will need to be installed on the exhaust of each one of the heaters that are in a common vent system. Now, the further we go into more heaters, and there's depending on how many heaters and how far we go, that vent system could be up to 10 inches. So anywhere from 4 to 10 inches would be our common vent size. If we do common vent, and this is in the instructions for the common vent installation, we do have to set the vent dip switches for the maximum vent length regardless of how far it goes.
So once we have everything installed, we may need to look at the dip switches to make sure that we have them set in the proper position, correct?
That's right. So we've got some dip switches that are going to be on the control board, and what these do is these allow us to give the heater information about the installation. So how long the vent pipe is and what diameter is so that it can determine how much air it needs to move to overcome whatever distances that we have. There's some other dip switches on there that we might set for temperature. Now, if we have a heater that we're using the user interface module or the remote control, all our temperatures are going to be set using this.
Okay.
But if something should happen to one of those, or if we're hooking up an outdoor heater and not using a remote control, we can set, with our 540, we can set it for 140 or 120 degrees, and the heater will still operate.
And so when we're looking at the manual or we're looking at our maintenance sheet, we're only going to adjust the ones that are in black, correct?
Yeah, that's very important. So when we look, especially if you're looking in the manual, there are different dip switch settings in different places depending on what settings you're trying to adjust for. So only adjust the dip switches that are marked with the black arrow in those illustrations.
Okay.
Or I'm sorry, the black square. The rest of the dip switches, it will show them, but it won't show a position. And a common thing to do is to think that that means they should be off. And if you turn them all off, you'll end up with a 031 error code, which is an incorrect dip switch settings. And that's easy to fix. We get our maintenance sheet out, and it has all of our dip switch settings actually in one location, so we don't have to go through the manual and find them in all those different areas. And just go through setting by setting and set them. One other thing that we may have to adjust for, that would be a dip switch adjustment on installation, is if we're installing these at higher altitudes. So as we go up in altitude, the air becomes thinner, meaning less oxygen. So we have to move more air, and oxygen is really the key component to combustion.
Okay.
So as we go up, we're going to need to move more air to make sure we have enough oxygen. So there is a dip switch for that, and it's about every 2,000 feet. But fall back to the installation manual. That's going to vary from heater to heater.
Yeah, and if you're using the maintenance sheet, remember that those maintenance sheets are unique to that heater. So there's not like one maintenance sheet for all the water heaters. It's unique to, say, the 540. That maintenance sheet is unique to that.
Cool.
One thing that is pretty unique with these heaters is we're able to easy link up to 4 units together.
Yeah, and with the Easy Link comes in the manual here, or in the back with the manual. I'm going to grab one real quick. All right, so the Easy Link cable that comes with the heater, now it's got a male plug-in, and it's got a female plug-in. So it's really hard to get this hooked up wrong as long as you follow a couple of very few basic guidelines as we're hooking these up inside the heater.
Okay, so what actually happens whenever you do link these up? I mean, how does it work?
Right, so we can hook up to 4, so it could be 2, 3, or 4, but up to 4 we can use just with the hardware in the box.
Okay.
Now the piping does have to be reverse return piping, and there's examples of reverse return piping that are in the installation manual that show you how these need to be piped, and that is critical for the first step.
All right.
Now once they're all connected and working together, under light demands, one heater will come on, and as the demand increases, we need more flow for hot water. It will bring on consecutive heaters based on the amount of flow that it sees and the need.
Okay.
They will also take turns being the first heater to come on, so that it's not always the very first heater that's in the series that comes on and the rest of them get used as they're needed. They'll actually switch and take turns so that we get even wear across all of the heaters.
Makes sense. So how do you hook these up?
We have the male and female connections on the Easy Link cable. Now all of our connections are going to go like we would in a typical plumbing system, male to female.
Okay.
So the female end is going to go into our first heater, and you're going to notice that there's 2 male plugs, but one of them is labeled parent, and this is always going to be the first heater. And we're going to connect that female connection to the male parent connector.
Okay.
And then we go to our second heater. Now we've got the male end of a plug that comes in, and if you'll look, there's only one female connection where this can land. So this is going to land on the number 1 connection.
Okay.
Okay. Now back at our first heater, and this is critical, we need to make sure that we turn the dip switch on the 540. It's the lower bank of dip switches, the top dip switch. Turn that on to let it know that it is the parent heater and it needs to communicate to the rest. This is the only dip switch that we change for this.
Okay.
Now when I come out of the second heater, I'm going to come from the other male plug that doesn't say parent. This is going to be number 2. But if you remember that the parent plug is only used on the first heater,
Right.
that makes it easier to remember how this gets installed. So with my second cable, I'm going to connect the female end to the number 2 connection, and then into my third heater, my male end then goes back into the number 1 connection. And we're going to repeat that process up to 4 heaters.
Okay. All right. So and you can link 4 out of the box, and it can be controlled without anything like an external control, correct?
Yeah, we don't need any extra things to do that. Everything that we're going to need is going to come in the box. Now that is limited to our models that are 199,000 BTUs or greater.
Okay. So what if we want to, link up to more, like 10?
Okay, so if we need to go above 4 heaters on a common water system, we can use, and this one we will have to purchase an extra component, and that's our multi-unit control.
Okay.
And it looks kind of like a heater that's in the box, but when we take the front cover off, it's really just a big control board.
Okay.
Now there are 4 connections across the bottom that are going to control 4 different banks of heaters, and we're going to have up to 5 heaters in each bank.
Okay.
Now this one, we are going to make our first connection using 2-conductor 20-gauge stat wire. And if you use 18-gauge stat wire, which is what a lot of people have, that's okay too. But we're going to make that first connection. We're going to go over to our first heater. And we're going to make that to the Unit 1 connections there at the bottom of the multi-unit control. Now we're going to come out and we're going to end up cutting off the female plug. And we're going to strip those wires back, and we're going to wire nut or using a splice connector, connect those to our wires that are coming back from our multi-unit control.
Okay.
The male end is going to go into the first heater. Now, since this is the first heater, we've got the male end, there's only one place that it can go. And it's important, we're not going to use the parent connection on any of these heaters, no matter how many we go to. Okay. And we can go up to 20 heaters with the multi-unit control.
Okay.
So the male end is going to connect into our number 1 plug. And then we're going to follow the same process, just like we did with our EasyLink connection. With our second cable, our female plugs into the number 2 connection, and our male goes to the next heater and plugs back into the number 1 connection. And we're going to repeat that process up to 5 heaters on that first bank.
Okay.
Now, once we get to 5, we will have to switch and go and make another connection back to our multi-unit controller using a separate 2-conductor wire that comes out to our second bank. But we're going to follow that same practice. We're going to cut the female plug off of our first cable, make those connections. The male plug goes into the first one, and it's going to connect to the number 1 connection, female to the number 2 connection, and our male end is going to go to our next heater. And we're going to follow that down. And we're going to keep doing that for each bank of 5.
So they're in banks of 5.
They are. Now, you do have to have 5 in a bank before we look for the next bank of 5.
Okay.
So if we had an odd number, say 8 or 9, we couldn't have 3 or 4 on the first bank and then 5 on the second bank. It would have to be 5 on the first bank and then the remainder on the next bank.
Yeah, so just make sure you're doing that in groups of 5. So that, like you said, if you had 8 heaters, you'll do 5 on the first and 3 on the second.
Right.
Okay, makes
Now,
sense.
while we're doing all these connections, it's important that the multi-unit control needs to have power,
Okay.
but it needs to be in the standby mode. So we're going to press the on-off button that's on the remote control for the multi-unit control. And we may have to press it once to wake it up and again to get the orange light, but we're going to press it until the orange standby light goes off.
Okay.
Now the multi-unit control still has power, and then all of our individual heaters need to be powered off. So we're going to power on the first heater on bank 1 and let it run through its self-diagnostic, and we're going to wait until one of the red LEDs on the multi-unit control board lights up.
Does it matter which one?
It may light up 1, 2, 3, 4, 5, or depending on how the controller is communicating with the heaters, it may light up a random number.
Okay.
But as long as one of those LEDs lights up, that means that it's established communication and we're okay. Once that happens, then we can go to the next heater, the second heater in the first bank, and we're going to turn it on, wait for it to finish its diagnostics, and again, wait for that red light to come on the multi-unit control. Once that comes on, we've established communication. We're going to repeat that process heater by heater, all the way up to the 20 heaters if we have 20 heaters.
Okay, and all of this is in the manual with the multi-unit controller?
Yeah, so the multi-unit controller comes with a small manual that explains this process. But one of the things that people overlook is getting that orange LED off.
Right.
And if that orange LED is on the remote control, while we're making these connections, it's not looking to establish communications.
All right. So that's the multi-unit controller and the EasyLink. Now, you know, and that's pretty much when we're talking about installation, we've kind of covered everything, connection by connection. But really, there could be a couple of situations because of installation that you can get some error codes. So this is kind of the troubleshooting, the installation section of this course. So really, what are the 2 or 3 different scenarios?
Well, actually, the first one, which is pretty common, actually won't give you a troubleshooting code.
Okay.
So this may be that you have no water coming out of your fixture when you open up, or if you have water coming out, the water heater may not respond.
Okay.
So a couple of things that we want to do, and this falls back on the installation. Make sure that the hot and cold connections are connected correctly and they're not reversed.
Okay, that's a big one. Yeah.
At the bottom of the heater there at our cold water inlet, there's a filter.
Okay.
And so you'll want to check, because when we install something, we can knock things loose in the plumbing and we may get some debris in that filter. It doesn't take very much for that filter to be blocked up where we can't see flow.
Okay.
So you isolate the water heater there, turn the water supply off, remove that filter, remove any debris, and that should take care
Is
of
it
it.
a good idea to do that after you've installed it, after a few days?
It is, after a few days or even after you install it, just kind of go and open up all the fixtures in the house, let them run for a few minutes, and then come back and clean that. And you still may end up having to come back and do that after a couple of days.
Okay.
And that may actually happen further on down, not related to the fresh to the installation, but if they've done any work on any of the other plumbing, either in the street or in the home, that can knock some of that debris loose.
Yeah, because when you turn off the water, you can knock some of that loose when you turn it back on. All right, what's another situation you might run into?
Well, and I'm going to kind of jump ahead because we need
Okay.
to talk about our specialty product, the pump model.
Okay, all right.
So the pump model is expecting to see flow. We may get a 441 error code when the pump tries to run, saying that the pump is running, but it doesn't see flow. So on that separate connection, again, there is another filter. And especially if we've used copper, we can get flux and things that collect in that filter. So if you get a 441, kind of kind of be the same thing. We want to isolate that, remove that filter, and I would remove both of them at that point, and just flush those back out.
All right. So that's if you're not getting any flow, or if you, really watch for the reverse connections, because you'll still get flow on those situations, but it's not going to read.
It's not going to read. And occasionally when the filter's dirty, it will still allow some flow through there, but not with enough velocity to turn the impeller. So.
Okay. All right. What's another situation you might run into with installation?
Another big one that we see is the 111 error code, which is ignition failure.
Okay.
And a lot of times this happens because we've made our gas connection, but we have air in the gas line.
Exactly.
Right.
Yeah.
So when we install that, that's all filled with air, and we've got to get that air out. So you want your gas contractor, if you are the gas contractor, make sure that you bleed all that air out of that gas line, and you've got gas up to the heater.
Okay, so air in the gas line, because really you're going to be troubleshooting it. You're going to look through the sight glass, or you probably won't see a flame in that situation. So you just need to get the air out of there. Anything else we want to talk about?
So the 991 code, and this is really common. Now this normally won't happen when you first turn the water heater on, because it takes a little bit of time for this one to actually develop.
Okay.
So our water heater, we're looking at the combustion values, and we're always trying to maintain the perfect mix between oxygen and fuel so that we burn clean. When we don't burn clean, we can create some byproducts that can damage the heat exchanger and the water heater.
Okay.
So if it sees combustion that it's not happy with, it will try and adjust the fan speed to get that air-fuel mixture correct. And if it can't, we'll get a 991 error code, which just means bad combustion.
Okay.
Now, that comes down to two pretty simple things that can actually be pretty complicated to diagnose. But it comes down to you don't have enough gas or you don't have enough air.
Okay.
Now, the gas is normally pretty easy. Make sure that it's correctly sized and that we've got an appropriately sized regulator, and that the gas is not only correctly sized for this heater, but for all the other gas
That's
appliances.
a big deal. Yep.
Now, if you are a gas contractor and you're using a digital manometer, we can check our gas pressure inlet here at the bottom, and we want to check our static pressure, which is with nothing running.
Right.
And then to check the dynamic pressure, which is with the heater running.
And everything else running, too.
And everything else running.
Yeah.
But very specifically, the heater needs to be running at its full input. So if we just have a fixture open like a hand washing sink, this isn't going to be running, it's not going to be using very much gas. So we really want to open up a bathtub or maybe as many fixtures as possible to make sure that this is running, trying to use all the gas. And we want to compare those pressures, that static pressure to that dynamic pressure when it's running. And if it's more than 1.5 inches of water column difference, we don't have enough gas.
Okay, so we're just looking for that 1 to 1.5 inches drop. And if we have anything more than that, then we're going to have to get a larger, probably a larger size gas line coming to the heater, right?
It could be a larger size gas line because of the length. It may be that the gas meter outside doesn't allow enough gas to come through because it's got a regulator, or we may have a bad regulator. Any number of things could cause that, and unfortunately we can't cover all of those different possibilities, but get a qualified gas contractor out there to look at that.
Okay. Anything else you want to cover on troubleshooting the installation? Well, the other side of 111. You're right. Yeah.
Yeah. So the other side of 991 is going to be the air, and air for the most part should be pretty easy. Let's double check our venting.
Okay.
Make sure that we've used the correct size pipe.
Okay.
For the length that we have to overcome, and that we haven't used too many fittings, so that all of that comes into the right play. And then make sure that we've set the dip switches correctly so that the heater knows how much pipe it has. Also, if we've put it in at altitude, and maybe you didn't remember to set those altitude dip switches. So dip switches play a critical part, as well as making sure that it's installed the way that the manual says that it needs to be.
And you can always look at your dip switches with the maintenance sheet that's on the inside cover.
The last thing with air, and there could be a whole lot more things that get more complicated, but we don't see them very typically. But the last thing with air is we may be recirculating those flue gases.
Right.
So if we haven't installed our terminations with the right amount of separation, and we're pulling in that same exhaust gas, or even exhaust gas from, like I said, a furnace or a dryer, something else that's going to use gas, that's going to cause us not to have enough oxygen, and that can also trigger this error.
Okay. All right. So that's a little bit about the troubleshooting on the installation, and we just covered, point by point on the installation. But now let's take a look at maintenance. All right, so let's talk about maintenance. With these heaters, we do require some maintenance, especially if we're not using a product preserver. If we are using a product preserver, our maintenance is kind of cut in half, isn't it?
It really is. If we're using a product preserver, so a big part of the maintenance that we're going to do is to remove those hard water minerals that are going to accumulate on the inside of the heat exchanger.
Right.
To prevent damage from happening. So descaling. When we descale, we're going to use food grade vinegar, but it is an acid.
Right.
So if we're using the product preserver, we're not going to have any accumulation that builds up on the heat exchanger.
Right.
And if we run an acid through there, we're just going to start to degrade the copper and,
Right.
and eat away the copper. So there's no need to do that if we're using a product preserver.
Yeah, because people always say, I should just go ahead and descale it even if I'm using it. But really, yeah, we can actually harm the copper, right?
Yeah, so we can actually do some damage. Now, if we are using a water softener or we're not using any water treatment at all, maybe we've got some pretty decent water to begin with and decided we're between the 4 and 7 grains per hardness and I don't need to treat the water, I'm just going to do the maintenance. Then we do need to do the maintenance.
Okay.
And maintenance, that's half of the maintenance really, is descaling the water heater.
Yeah, okay. So one of the things you can do is, take the cover off, check inside, check for any debris because we may be pulling in some contaminants, maybe some, debris on the inside, especially if you see it on the inside of the jacket. Go ahead, or inside of the cabinet, go ahead and clean that out. Yeah. There may be, you might have to pull the burner from time to time depending on what you're pulling in, right?
Yeah, so if you look here underneath the intake, you're going to see that we've got a little shield there that comes in to flex it. And so all along this edge, if we've been pulling in lint, grass, or even insects because we're near a porch light, whatever we may be, dirt, we're going to see that accumulate here along the edge, and we're going to see it accumulate along the bottom. And if it's just a light accumulation, let's go ahead and get that out. We may need to take an air compressor and blow off the fan blades. But if you're seeing a significant buildup of debris along those areas, it may be a good idea then to go ahead and pull the burner and blow air backwards through the burner to get any debris out.
Okay, all right, so you can go ahead and clean that burner. But you'll notice that because you'll see a lot of debris.
Yeah, there'll be a significant amount of debris in here.
And we're pulling it up through the fan.
And we'll normally see some other things. Once we get to that point, we'll start to see more ignition failures between the 111 and 121 code, which are both ignition failures, or we may see a 991 code. There are going to be some other symptoms that lead us up to pulling that burner.
Okay, before we descale it, is there anything else we want to talk about?
So before we descale it, and when we descale it, what we're doing is, again, we're removing those hard water minerals, and what we're going to use is 5% acid white vinegar. It's a food safe. This is something that you're going to use in cooking.
Right.
So you're going to have it in your home, so wherever you buy your groceries, just get that there. We're going to need 3 gallons of that.
Okay.
We're also going to need a 5-gallon bucket to hold all that.
Okay.
We're going to need a couple of washing machine hoses.
All right.
And then we've got a transfer pump here.
All right.
So it doesn't have to be a very powerful transfer pump, but it needs to be able to pump the solution through there. Now, before we can pump it through the heater itself, some models have a bypass valve.
Okay.
And what the bypass valve does is it allows us to run a little higher temperatures so that we can protect from condensation.
Right.
And if you're not sure if you have a bypass valve or not, it's a good idea just to go ahead and do this part of the procedure regardless, because it's not going to hurt.
Okay.
That bypass valve will actually take and mix a little bit of cold water back in so that we can get the temperature out, because we've heated it up a little bit higher in the heat exchanger to protect the heater.
Okay.
So when that bypass valve is open, it's allowing a very easy connection between the hot and cold inlet and outlet.
Okay.
So if that's not closed, it will just pump through that and it won't pump through the heat exchanger.
Right.
Right. So to close that, we're going to get the temperature up above 130 degrees, and so we need to take it to 140.
Okay.
Okay. And so with the power on, and to get it to go above 120, you see we're going to have a safety lock out here at 120. It's the hot and info buttons for about 3 seconds, and it'll flash 125. Take that on up to 140 degrees,
Okay.
and now we got to get the heater to run.
Okay.
So we're going to open up a fixture, probably a bathtub, but any fixture, because we just need to have 140 degrees. That's going to close that valve. Now, once we have the heater running, if you press the info button, oh, I've pressed it too many times, and you look at the outlet temperature, you'll be able to see the temperature leaving. Once that gets up to 140, we're just going to unplug the heater.
So we don't turn it off. We don't turn off the water. We just unplug it.
Yeah, once we unplug the heater, because that bypass valve, it takes electricity to close and open, and we've got it closed now, it can't possibly open. Now when we run our solution through there, we're going to actually descale or delime the heat exchanger.
Okay, so yeah, before you hook up any of your hoses, before you do anything, it's best to go ahead and get that temperature up to 140 degrees, and then make sure you got it, check the temperature, then go ahead and just unplug it. Now we can hook up our hoses and we can go ahead and run our solution through.
Absolutely.
And that's going to be about, what, 45 minutes?
Yeah, we want to run that solution through for 45 minutes. Now we do have some temperature safeties in here, so if we get too much scale buildup in there, we're going to get a 711 code.
Okay.
That'll start with an ignition failure, but then when we follow that process, we'll get a 711 code, and that means it's time to descale the heater. So 45 minutes, we shouldn't be able to get any more accumulation inside that we wouldn't be able to get out in 45 minutes.
Yeah, and we have our isolation kit on here, so because with every heater that we're selling, we're going to have one of these.
Yeah, we want to make sure that these get installed, and for this reason.
Yeah, so you can go ahead, isolate the heater. That's when we'll put our hoses on. We'll run our solution through 45 minutes. And if you have a lot of buildup on the inside, we're pulling something in from the outside. During that 45 minutes, that's a good time. You can go ahead and clean the burner and do other things while you're waiting for that to descale. Now, what does it look like? Is a lot of stuff going to come out of it? Or?
There's really not, because you don't see it when it goes in. It's dissolved in the water. So most of the time you won't see anything coming out as you're descaling, because we're redissolving those minerals back now into the vinegar, the acid vinegar.
Okay.
You may see a flake or something come off if we've got some significant scale buildup. As it breaks down, we may see a couple of flakes, but you're not going to see a whole lot come out. Just run it for that 45 minutes, and at the end of that, you'll be in good shape.
And it's a good idea to go ahead and run the temperature up on all water heaters, all the tankless water heaters, just so you get in the habit.
Yeah, get in the habit, because you may not know if you have a bypass valve or not. We know that it's limited to the 199,000 BTUs and up models. But if you're not sure, and this is just a quick and easy way, it doesn't hurt, just do it on all of the water heaters. Run it up to 140 and then unplug it. So,
yeah, because if you don't do it, you're going to have a really, really clean bypass.
Yeah.
And miss the whole other part of the heater.
And if we don't unplug it, we've still got it set for 140, and we try to run the vinegar solution through there while it's plugged in, the heater's going to try to heat, and we don't want the heater to try to operate, so it has to be unplugged.
Yeah, the power has to be off. All right, anything else we want to talk about when we're dealing with maintenance?
I think that covers it as far as the general maintenance, beyond what you may have as far as repairs, where you're going to have a professional come in.
Okay, so that's maintenance on tankless water heaters.